So we'll have two speakers on stage coming up next. Mays is an electrical engineer by education with 25 plus years of experience in building software. He strongly believes in the concept of journeyman years, which never end. This helped him to think outside the box and to draw parallels to seemingly unrelated domains. He embraces legacy systems and tries to give them, wherever reasonably possible, a new life. Gergely Bekic's interest in computers started in 1989, and it never faded. He worked for different projects in various companies before joining Tesco. It doesn't matter if the code is old or shiny, as long as the software has a meaningful purpose, he's happy to participate. The title of their talk is Cost Optimization as Part of the Software Development Lifecycle. Please welcome on stage Matthias Reik and Gergely Bekic. A round of applause.
Thanks, Peter. Yeah. Where do we have the... Oh, okay. Hello, everyone. It's really nice to see you coming to this talk, and it looks really like a lot of people are interested in looking at cost optimization, and it's really good to see that. I know it's lunchtime, so I'm standing a little bit between this presentation and lunch, so we'll get going. To start with, let's talk a little bit about myself. You have heard already an introduction, but what am I doing in Tesco? So I'm head of software development. I'm responsible for the commercial systems within Tesco, i.e. with the systems that my teams create, we make commercial agreements with our suppliers for how much do we buy in the product, how much should you pay in the shop, and similar things. And then we have my colleague, Gergely. So Gergely.
Yes. Hello everyone, and thank you for coming. I am working as a principal software development engineer, which basically means that if something goes wrong, it's me. I have to fix it. That's fine. I am working usually with multiple teams and working between those teams because what we see that if it's a technical problem, then all the teams can see that, yeah, everything is fine in our end and it's still not running. So my job to make sure that things are running as smoothly as possible in our environment.
Thank you, Gergely. And then let's talk a little bit about Tesco, because if you're not from the UK or from the islands, Republic of Ireland as well, or from Hungary, Czech Republic or Slovakia, you might not even know who Tesco is. So Tesco is a leading multinational retailer with more than 330,000 employees. So Tesco is really, really big, and you might not even have heard of it depending on the country you're coming from. And we are trying to serve our customers really in a good way, because we are bringing the food onto the table. Tesco is present, as I said, kind of mainly here in Central Europe and in the UK. Tech hubs, we have tech hubs in the UK, obviously. That's where the whole company started. In India, and then even in Poland and here in Hungary. So I'm coming here from the Hungarian tech hub. Oops, sorry. Motivation for this talk. So why am I talking about that, the cost and bringing cost optimization as part of the software development lifecycle? It really is about, what I've seen so far is that very often cost is often an afterthought. We develop something to deliver features, and then we have it in production and we run it, and then we realize, oops, that's pretty expensive. And that's not really ideal. Or the opposite is that the company is very cost constrained and cost is really a concern and limiting things very much. Now, each of us developing things, we are really expensive. So cost should really be in our mind. Running our systems is expensive, so we need to bring the value. And it's usually not a problem to spend money if the value is there. So there's return of investment, really. And here's a bit of an example from one of our areas within Tesco. And no, those numbers are not the total numbers of our cost, but it gives you a little bit of an idea of what the potential is. So in that one area that I take here as an example, we are spending about 3 million British pounds in cloud cost. That's quite a lot of money. We looked at how much can we reduce that cost, and we identified that about 1.8 million we are wasting. We don't need to spend. That's the potential we can reduce it. Now, some of those things that we would need to do are very easy to do, some are more complicated. But you see that half of the money we spend currently, we could reduce. Now, those numbers are a little bit outdated because we have done a lot of effort. That's when we started to look at it. And we have reduced by about 600,000 British pounds over the last year or something like that. So there's an enormous potential in this. And that's the reason also why I really want to encourage people to look at cost not as an afterthought, but to really take it into the software development lifecycle. So where do we have the biggest cost? So one of the big things is underusage. We are running an infrastructure, but actually it's not really used that much. So what can be the reasons for that? Reason number one is everyone loves microservices, and they are great. And then of course, if you're running a business, you want to be highly available. So you spin up at least 2 instances. Even so, from a load perspective, it might not be required. That is definitely something I see in my area, where we have our suppliers logging into our systems and making some negotiations with our so-called buyers, so the people from Tesco. What should be the cost for that product? So how much should Tesco pay for that product when they buy it in? Of course, there's a lot of those suppliers and there's a lot of buyers, but we don't change the cost that often. So it's like, okay, we really need to have it high available because constantly there are changes, but the load is not very high. And we looked at it and we figured out that our AKS, Azure Kubernetes cluster, the usage of it is at about 10%. So 90% of the resources are wasted. Now, you don't want to run your system at 90% or even 100%, because as soon as there's a little bit of an extra load, your system might fail. But you definitely do not want to stand at just 10%. Yeah. The other thing we identified is that we have a lot of databases. Every microservice has its own database. Fantastic. That makes us very independent. But it means we need to have kind of a container where we run that database, or a server, or whatever it is. And here again, we are wasting a lot of resources. And when it comes to high availability, you have the extra node up and running, but it's not used. It's just there for the case that the other one goes down for whatever reason. Bugs or, well, we never have bugs, obviously. The other thing is ignoring the access patterns. How many of you are switching off their test systems during weekends? 3, 4 people. Wow, that's fine. There are some more people standing here. What are you doing? You leave them running? Or you don't have test systems? That's even more scary. So just look at when are the systems needed. Are we using it? Are we doing something with it? Is our pipeline running during the weekends when no one is doing any commits? Because we say every hour we want to test that our build is still fine. You might have reserved instances that you actually don't need, but they're reserved and you have to pay for them. And you might even over-provision. Maybe you have 3 Kubernetes nodes running, even so actually 2 would be enough, even to fulfill the high availability. So just look at what do you actually need. What is my access pattern to my systems? And then determine what can you do. And switching off your instances during the weekend, your test systems, is a decently easy one. This can be automated. Talking about those databases, every little microservice has its own database. Fantastic, but it's a waste. So shared services is the magic word here. And shared services are great. And whether they are shared services in the cloud or not, AWS has a lot of shared services. Azure has a lot of all of the big providers have shared services that they provide, and they are really, really good. And it takes away a worry from your engineering teams, because basically the cloud provider, whether it's a private cloud or a public cloud, will take care of running those services, making sure they are up and running, making sure that they are upgraded and the latest patches are played in. And you don't need to have this administrative deep knowledge of the different systems, of a database, because maintaining and keeping a service up and running does need a bit of knowledge. Anyone has been maintaining a Kafka cluster? No? Okay, one person. You probably know what the pain is then in making sure that it's configured properly, that it performs well. To kind of move maybe your partitions over from one node to another when you integrate one because they go out of balance. And it's very nice, those shared services, those problems are taken away from you and you can focus on the real things. This shared services doesn't mean that your team needs to give away ownership. In our case, we always keep the ownership with the teams. They say, I need to have that database, that's the schema, and so on. Yeah? Very important. Now, there are some downsides with shared services as well. And one of them is that they usually just work for some commodity use cases. If you want to hammer the database with calls, as from a certain point, the shared services won't work well for you anymore. And you probably will have to have your own database server. But those are pretty rare cases. They do happen, especially in more the area where Gerge is working. But in the area where I'm working, a database is really a commodity. You add a certain agreement with the supplier, we add a record in a database. It's not heavily loaded. And I'm pretty sure that most people have those requirements and their shared service really works fine. And then the other problem is that shared services are often charged as a premium. At least when the data volume goes up, it becomes pretty expensive. Whether that's the case for you, you're going to have to make that call. In our case, we actually said, instead of asking the cloud providers to run the shared services, we do run them. So we take a normal instance and we set up the services. We have a team that is specialized just for that. And that brings me to the topic of public versus private cloud. Public cloud is fantastic. There's a lot of good things about the public cloud. They do offer kind of a lot of those shared services. If you would need to replicate that in your private cloud, that becomes really, really expensive. The public cloud is very mature. If you start to build up your own private cloud, probably it won't have the same maturity level. You don't have that much experience basically with it. And so the stability of public cloud is really, really good. And getting to that same stability takes a lot of investment up front. So the private cloud is expensive to build up, but as from a certain size, it does make sense. So in the case of Tesco, we do have a private cloud. And if I compare the cost between our private cloud and the public cloud, depends a little bit how you count, but you can count with we are a fifth to an eighth of the cost of running in the public cloud. There is an enormously big price difference between the two. And then private cloud makes, of course, GDPR much easier. So where should you put your stuff? Well, it depends, obviously, how big, how small your company is. It depends on how important some of the aspects are, like I want to have the data in my own data center. can be very important. So I cannot give you any recommendation. It's more about you to think about it. And in the scale of Tesco, we definitely do want to run things ourselves. But not just, because there are certain use cases, certain services that are very, very expensive to replicate that cloud providers have. And I mentioned that one. That's the reason why we are using this hybrid cloud approach, where we basically say, we take the benefits of our private cloud, the standard use cases that kind of everyone has, we build them ourselves, we maintain them ourselves. But then there are certain things where Azure is just better, and we use that one. Now, there comes a problem with that. Where do you put your workload? Which workload do you put where? And there's a couple of costs, and that's the reason why I'm talking about this as well. There are a couple of cost things you should need to consider. And that's the traffic. You pay for the traffic in and out to cloud providers. So look at where you put your workload. Where do you place them? In the cloud? Outside the cloud? How are your systems communicating with each other? If you constantly move data back in and out, kind of north-south traffic, that can become pretty expensive. So look at that east-west traffic is kind of in the same place. You can't do it all the time, but it's still a good practice to take a look at that. Oops, wrong button. Sorry for that. And with that, I hand over to Gergely to talk a little bit more about his area.
Yeah. So Maze told mostly about the cloud, which is a great place. But we have a lot of other areas. But let's first start with the cost. So there are traditional software development costs, like salary. I get money for being here on the stage, which is great. We also have an office. Nice office, costs a lot of money. We have computers, workstations, servers, whether it's on-premise or in the cloud. We have to pay money for them. We have to pay for licenses. We also paying maintenance and support fees for a lot of stuff what we have. So that's the traditional cost of any software development. However, there are hidden costs. The first one is the cost of missed opportunity. What happens if we can't deliver something in time? But is it some fines from regulators? Yeah, we can get that. That's, you can decide. It's basically a cost-benefit ratio. We will lose some income, and also we might lose customer. That's the last thing what we really want. Tesco is a retail business. Basically, our main source of income are customers. So we really, really care about not missing an opportunity. The other hidden cost is the cost of failure. What happens if we mess up? Like, I use index cards. I know it's old school, but it's here. Doesn't matter if you have electricity or not. It does work. I can read my notes. If this thing goes off, I still can continue the presentation, because the cost of failure for me here is just too high. And we have the same thing with Tesco. If we can't do retail in the stores, it basically means people won't have access to food. It sounds an over-exaggeration, but it isn't. It really happens. It could happen. We are trying to make sure that it won't happen at all. We will lose reputation if there's a failure. Tabloids love Tesco, especially when we make some mistakes. And also we will lose income. And that's the third thing, and really the most important priority, that the service we are providing, people are trusting us, and they really want to get food. I like food, but it looks like others as well. So we have an architecture which is basically an edge and cloud model. I don't know if we have a word for that, because it's obviously not hybrid cloud, but it's a very hybrid solution. So all our stores in an edge model, which basically means all the data which we need to operate is in the store. So if we lose network connectivity, things happen. Doesn't matter, we will still sell sandwiches and breads and whatever you would like to buy, you can buy them in Tesco. However, with the edge word, it means that we have physical things which are resource constrained. It's not like the cloud that I need another 5 databases. Yeah, we can do that. We are full. We have a lot of resource constraints: CPU, RAM, disk. We are using handsets. Those handsets, we have about 75,000 scan-as-you-go handsets. Half of them has just 1 gigabyte of RAM. We have to live with that. You can't, magically replace about 38,000 handsets. That's a lot of money, plus an insane amount of work to do. We have tills in our stores. All the tills can work by themselves. So if we have electricity, we can serve customers. But it means that every single till has about 40 microservices, and they have to work somehow together. And that's just one single computer. In terms of high availability, yeah, we have like 86 tills. If one goes wrong, who cares? We have rather 80 something. So it's a bit different way of seeing things. So we have this shared environment, which is very traditional in Edge. And my colleague, Laurent Kovacs, he will have, he's there by the way, he will have a talk just about these shared environments and how they are trying to manage about 40,000 tills in the near future. So the thing is, IOPS is one of our biggest enemy, because with RAM, with CPU, you can more or less utilize. With IOPS, it's quite random. If something starts working and doing a lot of stuff, doing a lot of reads or writes, what happens with other services who also would like to write? So we have to be very, very careful of what sort of resource we are using, and it's really not just RAM and CPU. With storage as well, but storage is probably the least amount of problem. This is the easiest thing to add more is storage. You just pop in a new drive and you are basically good to go. With CPU or RAM, it's always a bit more difficult, as well as IOPS. We have to do a lot of coordination. We have to be backward compatible. Those 40 microservices must be able to communicate with each other. We are doing coordinated releases, not because we want to. It's more like because doing canary in roughly 5,000-6,000 stores, it's not a simple thing to do. And it takes time. A traditional release in Edge takes roughly a week. So if you are not in the canary cutoff, your thing won't hit production for a week. It just takes time. It takes time to roll out because, as I said, cost of failure is so insanely high that we are saying that even it's much better to lose an opportunity than having a failure in our system. So we are very, very cautious here. We have couple of shared components, mostly about communication, because we would like to control how these microservices communicate to each other. And we have a shared tech stack, which kind of makes sense. It's very lenient, so it's not like you have to use that version of Java with that version of Spring Boot or Micronaut or .NET or whatever. We have a fairly long list what you can use and you can choose. And if you would like to do an experiment, that's always doable. But we have our limits. Something what we don't want to do, like for example, we don't have .NET in our tills because it's just additional cost of license, and also our stack in the till is more JavaScript and Java at the moment. And ownership. So what we need a very clear ownership structure. If something goes wrong, I want to know who is responsible, not for blaming somebody, but more like we need to find out fast what's going on, how can we mitigate, what are our options. Because time is money. If we don't have a store for a day, that's basically lost money. And it's not just services, it's platform as well. What about logs? How are logs forwarded? Do the log forwarder works? Maybe not, that's a problem. And there are bits and pieces in between, as I mentioned in the beginning. So somebody has to be there and pick up that and make sure that everything is running smoothly end to end. We need observability. Mihai Tóth will have a talk about how we plan to monitor those 40,000 tills. And the thing with observability, that our network is finite. It's not like cloud, when you basically have almost infinite network between two instances. We have very high constraint on networks. We have stores which runs on 4G. And just about log sizes and metrics, just one single component out of those 40 on tills produces 2.6 terabytes of metrics in a single day. And we have 40 of them, which is quite a lot. So we have very sophisticated ways of sending our logs and metrics to our central, where we can do the further analysis and everything else. and also it costs money. Most log architecture priced based on ingestion. So if we are not sending the logs, that's plain saving. But of course, then we don't have the visibility, so we have to find a middle ground which gives us proper visibility, but still saving a lot of money. We are using distributed tracing next to the metrics because it's very hard to pinpoint what's the origin of any error, and we have network monitoring. We are working very hard to have a much better network monitoring what we have right now. It's a very tricky subject. We have to monitor Wi-Fi because our handsets communicate on Wi-Fi. An extra store is basically 3-4 times of this place where we are right now. There are network issues. It's just not possible to not have anything. And the funniest part, what we are currently experiencing, is code pollution. So if we are doing coding and if we are using metrics and logs, basically what I seen like yesterday or day before, we had a business method which was like about 10 lines long. The real part was 3 lines. If something to do and the end curly braces. That's all. Everything else was logs or metrics. So it just pollutes our code because we need those metrics, we need those log lines, but it makes the readability of our code, not the best. We are working very hard on it. We are trying to figure out a solution, but that's, I think, a very generic problem in our world, that we need the data, we need the visibility. We must make sure that we can fix if something goes wrong. However, it has a price. And yeah, we need control. So the traditional DR, BCP, and other 2 and 3 letter acronyms doesn't work in Edge. There is no AJ in the traditional sense in our world. It's just one single computer. But if it fails, we have another. If one of the scan as you shop handset fails, we have like 160 another. It's not who cares. It's more like we have time to fix, and we don't need to do traditional development in that way. We are using an insane amount of feature flags. That's, I think, probably true for all of you. Feature flags are fun, and it helps us a lot. We are trying to save as much network as possible. So we have quality of service. We are sending our logs and metrics in a very smart way, as I already mentioned. And we have distributed deployments. So we are talking about 4,000 TLs in the future. Currently, we have 28,000 or something TLs, which was developed by us. And if you would like to distribute a new Docker image, we don't want to send that image to every single one of these TLs. We just want to send to one in a single store, and then they should replicate themselves. We have an open source solution for that. It's called Aqueduct. It's in Tesco's GitHub page. If you would like to look up, it's fun. It's nice. It really works very well for Tesco. And we have offline mode, as I said. So we need full control. If anything goes wrong, TLs still should be working. We are doing a lot of testing. We are trying to automate as much as possible. We have a lot of physical devices, like scales. In a self-service checkout, you need at least 2 scales. We have physical scanners, which sometimes very hard to test in an automated way. We are trying. We have concept of rubberized fingers, so trying to automate even physical device testing, but it's not always there. So we still doing some manual testing in the physical world. And the biggest issue what we have, that we don't have the in-store environment. You just can't replicate in an office. Like, as I said, an extra, it's a huge store. We can't have a huge store next to our office, which does nothing. We have one extra store next to our office, but it actually does trading. So we can't do the exact way of testing. We have labs where we replicate whatever we can, but it's not the same if you're just talking about Wi-Fi. If I am standing here, my Wi-Fi is probably different than somebody who's standing in the other end of this space. So yeah, we can't test everything, but we are trying the best. And we have some algorithm. So basically, cost saving is, all about architecture, all about processes, all about how we are doing stuff. But it's also about algorithm. Andor Kelemen, another of my colleague, he will do a full speech about truck routing. It's basically how to get something from a Tesco store delivered to home. That's tricky. And we are talking about, if you save about 1 second of picking time, then we are talking about millions of pounds, usually. Tesco is a big retailer. We have loss prevention, which is about how to save money on shrink. So, for example, is it okay not to do second factor authentication on online shopping? That's frictionless checkout, or this is how it's called. So our customers will be happier. However, we are taking the blame if somebody stole a credit card and pays with that. So there are a lot of other bits and pieces. Maybe you would like to say something about machine learning?
Yeah, so in my area where we determine the cost and the price, it's very hard to figure out what is the correct price. You want to get as much money as possible from the customer, obviously, but you want to offer the product in the cheapest way. And you have to look at your competition as well. So it really is a bit of a trade-off of different things. And we can use machine learning to figure out what is the right price, how important are products, where do we want to compete, where do we not want to compete. And then also the other part is of when we look at the cost, to figure out, our suppliers are sometimes coming and saying, there's a war in Ukraine, we want to have 20% more money. Why? Well, cost went up. Did your cost go up, or you just wanted to use the opportunity to get more money as well? And a lot of the things, we have mechanisms in place that will help us to determine when is the right time to make a promotion, what is the right price for a product, where do we need to maybe let the machine do the price setting. We know what the cost is, because of that we need to manually agree with suppliers, and out from that, with all the expenses we have, we can actually determine what the right price should be. And for a lot of products, that's really what we want to do. So machine learning is an important aspect in that one, and it can reduce, not necessarily the cost, but the gain, and setting the right price.
Yes. And so just to summarize, we think that there is no silver bullet. We have to, like what Matthias mentioned about databases. Yes, some of our products will use dedicated databases, for the future as well. Some can use shared ones. It really depends. That's probably true for everything what we said. It really does depend. And yes, software development lifecycle should include the cost. You should start thinking about it. Is it really the best approach? Do we really need that database? Do we really need that dedicated server? Yeah, maybe yes. Maybe in the beginning, yes, you do need, and then later on you can change for something, a cheaper solution.
Yeah, and if you want to take something with you, it's really about looking at cost as part of the software development lifecycle. You're looking at security. You're looking at the non-functional requirements. So add cost to that list of things you do during the software development lifecycle.
Yeah, you should. And don't forget about the hidden cost, that it's really not just about salary. And measure everything. We are trying to measure everything. It's a pain. But when something goes wrong, this is the only thing what we have. Otherwise, we will start losing money, and we will start losing reputation, and people won't have food, which is not a good thing.
Good. That's it from our side. So we'll open it up for questions. Peter.
Thank you very much, gentlemen. Some questions already came in. Number one, how can you measure the hidden costs?
Well, yeah, it's very simple. If you are in the top of Daily Mail, that's not good. So what happens that you can't measure hidden cost. It's not possible. Our product works very hard to figure out how much money or what sort of opportunity one of our programs presents, but you can't really. We have estimation about how much money advertisements will make on a Scan As You Go device, which is one of our ongoing programs. It's a lot of money, but we are still being very, very cautious of not killing our network. I spent the last 2 months basically making sure that our network is stable, even though we start serving ads in 75,000 devices. You can measure, unfortunately. You can guess, you can have estimations. It usually came from product. They do a lot of experimenting, investigation, but you can't have an exact number here.
Thank
Yeah,
you.
it's very similar to what's the value of a feature. You can't say what the value of a feature is beforehand because, well, you will only know it afterwards. And afterwards, you don't know what would it be actually if I wouldn't have the feature. But you can do decently good guesses, and it's the same here. So if we don't do this new feature, that's the missed opportunity potentially. Yeah.
Thank you. Which public cloud services are hard to replicate in the private cloud? Could you share some examples?
Yes, absolutely. So you probably want to run things in different availability zones. And you need to have really a big infrastructure in order to offer something like that. And I guess there are very few companies that are of that scale. So that is definitely something where it gets harder. Having different regions, different availability zones, it gets increasingly harder. And you need to have the base, the amount of customers basically on your platform in order to allow that. It's not technically impossible or anything like that. Cloud providers are showing it, but it's just the investment is only worth as from a certain size. The other thing is that if you have your private cloud, you surely want to have certain resources available, but maybe our online shop gets now hit with Christmas. Christmas happens once a year. Should we really have that many resources available just for Christmas? It's like, no, we take the resources from a public cloud provider and scale our infrastructure during that period of time. So those are the things where it probably doesn't make sense for you to provide something like that. And what makes sense and what does not make sense depends really on your circumstances, on your company, on what you want to offer. And maybe you say, actually the database I provided myself because we use 20 times, 40 times a database, and we can save thereby the cost of Amazon running it. Maybe you say, no, actually, I'm so small, it doesn't make sense at all. I use everything.
Thank you. Next question. Do you have a solution against code pollution caused by the amount of metrics you mentioned?
Yes, we have. Our current experimenting is basically events. So most of our architecture are not event-driven or event-based architectures. But what we saw that if we emit events in the place where we should, these are synchronous events. So when we synchronous events or synchronous event processing, at that time it's just easier to read. So the fact that having like 3 lines of logging something because you have to start a new thread in the distributed tracing or something like that. So if you need 3 lines, that's annoying, that's hard to read. It takes time to understand. Comparing just having 1 or 2 lines when just simply throwing an event saying that that business thing started to happen. This is what we are trying to do, which means we will end up with a lot of events, small events with small payloads, but at least reading the business code will be easier. It's still not perfect. We can't use Aspect or AOP or something like that because it's just too generic. We really need full control over what we are sharing with our central systems.
All right. What technology stack are you using for your application performance monitoring?
Oh yeah, we are using a lot of stuff. Our tech stack is not it's not really a homogeneous construct. So for example, we have handsets, Android-based handsets. They used AppDynamics. Currently, they are using New Relic and their APM tool. In the edge computing, we are using Prometheus in the store, which collects all the metrics, and Prometheus pushes all this information to Victoria Metrics in the cloud, which is a replicated version of Prometheus. And then we are using Grafana for our metrics. For the logs, we are using Splunk in store. We have a Splunk forwarder, which picks up part of the logs all the time, and other part just if they are mentioned in some of our support tickets, and then they are automatically indexed and sent there. I think that's mostly what we are using. We also What else? Yeah, Edge. Maybe in the cloud we have something else. But I know that we do use Splunk a lot in the cloud as well.
Splunk is the main. New Relic, Splunk. Those are the standard things we are using.
New Relic, Splunk,
New Relic, yeah.
Victoria Metrics, Prometheus, Grafana. Yeah, Big Panda. And we might have something else as well.
Yeah, we do also use Google Analytics or things like that for our front-end application. So I think it's a platitude of solutions that we combine together.
That is indeed a lot. Next question is about money. How much of the 1.8 million in potential saving were you able to achieve? And what were the low-lying fruits?
Yeah, so as I mentioned, about 600,000 we have saved already. And those are kind of low-hanging fruits. So I went through them during the presentation. There are some more things we're doing, but I can't talk about those. But just purely by sharing the resources, that is really a low-hanging fruit. So that helps enormously. The other thing is, and that's a bit related to the architecture, what we have on the application that I have to maintain is we need to have audit trails. We do have then the data itself. We do need to be able to search through the data, and we have a bit of caching. So we had Redis, Elasticsearch, Postgres, and Cassandra. It's like, yeah, and each of those want to have their own servers and their own instances, and it's like, do we really need all of those? Just ask yourself, most of the data is, we just need the data set. And most of the queries, you don't need Elasticsearch really. If you do need, fair enough. And if you are sharing it with other teams, then that's maybe not even a problem that you have Elasticsearch up and running, because it's not idling most of the time. But if it's just for you and your own team, it's like, it's idling 99.995% of the time. That's an enormously big waste. So look at those things. Just use Postgres, for example. That would probably work for most of our use cases we have. There is no point in shuffling and copying the data. And copying data is actually pretty expensive. We are using a lot of resources by duplicated data, basically. So look at your architecture. How can you redesign some of your things? Now, that is an effort. That costs, so it must be worth the effort. So make sure you measure how much duplication do you have. Think carefully about those things. So that's my recommendation. And yeah, about 600K in that case.
Perfect.
But that's not the whole cost of Tesco, yeah? Let's make it clear. That was just from one area.
Yes, so there are a couple of interesting bits and pieces. Maybe the funniest one is disk. So in cloud, what sort of storage would you like to use? Do you really need that high performance storage? You can save a ton of money if you are choosing something which is, a slower version.
An archive the stuff.
Yeah, it takes a lot of, and changing one kind of storage to another, it's basically very simple. Yeah, you might have to migrate some data, but other than that, it's just basically changing something in Terraform and you are good to go. Utilization, that's a really big thing.
I can talk about the database. So I have legal requirements to keep all of those commercial contracts for at least 7 years. How often do we access the data? Well, while the negotiations is happening all the time. But then once the negotiation is over with the supplier, we only need the latest version. Everything else is, we can archive it. There's no point in keeping it around. Data volume is maybe not that big, but depending on your use case, that might be a ton of data, and that might cost you unnecessarily.
Yes.
And moving it to an archive is super cheap and easy to do.
Yeah, and the last thing, if you don't need something, remove it.
Yeah.
I know it sounds blatant, but it happens. Like we had Matrix, which was an insane amount of money, I think $500,000 a year or something like that. And we just removed that because we never really needed them. This is the cost of having that opportunity. We got there, but we developed a lot of unnecessary stuff, or which in retrospect was not necessary. Of course we thought that would be really important, but right now, no, we don't need. So if you can remove something, please do remove.
Yes.
Thank you very much. And the final question, let's do it lightning question style, as we have 2 minutes left only. Can you detail a little bit more on the percentages of savings once you started to use public or private cloud? Just some lightning round.
So we are doing the steps. So we're building up our private cloud, and we're on the move from public to private for some of our systems. I can't give you any concrete numbers, but as I said, the cost for the private cloud is 1/5 to 1/8 of public. Since we haven't migrated too much of it yet, I can give you a number how much we will save, basically. It's still kind of small numbers at this point in time. One of the things we have is we have a team that is providing all those shared services, and they are looking and moving to the private cloud in one big go, and then we can take a lot of applications very easily because they provide a framework that makes it very easy then to migrate over into the private cloud. And so that's kind of still work that is ongoing. But we are talking about hundreds of thousands, millions of pounds then again.
I can tell about the other cost, the cost of development. So if we are moving to one solution to another, it won't be the same. We are currently in the middle of moving our database from Azure to our Tesco public cloud, which is Tesco private cloud?
Private cloud. Private cloud.
TPC, everybody calls it TPC. So we are in the middle of this, and even though price-wise, yes, we will save a lot, however, we have to change some of our processes. TPC is not the same offering as Azure. It's much cheaper for a good reason, but it's not just not having profit, like Azure has profit, but it's more like, yes, we don't have the same offering. So for example, some of the stuff we have to still do via ticketing, which is not a good solution. We are working on it, but you have to factor in that once you move to private cloud, you will lose a couple of those insanely great advantages what you have in a public cloud. Not deal breaker, but that could happen.
Perfect. Thank you very much, gentlemen. A huge round of applause for Maze and Gergely, please.
Thank you.
Thank you very much.